So up on the screen, I've got our rules for the nth term. Yesterday, we learned a formula for the sum of n terms. What is the sum for n terms in a geometric sequence? A sub 1 times 1 minus r.
I don't know the name for it.
That's okay, it's a common ratio.
To the n.
To the n power, it's not always squared. To the n power over 1 minus r. Yes. So we did one sum yesterday, and we're going to start off class today with using this formula to find a sum. So I want to find the sum of n terms of the geometric sequence, given that a sub 4 is 27, r is 1/3, and n is 7. How many terms are we adding? Seven terms. What other information do I need if I'm going to use our formula for summation? We need a sub 1. We need our first term. How am I going to find the first term? How can we find the first term? Yes. So I'm using the general equation for the nth term. We're looking for the first term. So a sub 1 equals, we have the fourth term. So that's what I'm going to put here. A sub 4 times our common ratio, which is 1/3 to the power of 1 minus 4, yes. All right, we don't know what the first term is, so I'm going to leave that as a sub 1. What would I substitute in the place of a sub 4? 27. Times 1/3 to the -3 power. We talked about this briefly yesterday. When I have a negative exponent, what does that do to the base? It's going to flip it. It's going to turn it into the reciprocal. So what's the reciprocal of 1/3? 3. So I have a sub 1 equals 27 times 3 to the 3rd power. So what is the first term of this sequence? 729. We're going to use that in our summation formula. 729 times, what do I have in my numerator? 1 minus, yep, 1/3 to the power of 7 over what? 1 minus 1/3. So the sum of 7 terms is equal to 729 times, how is the denominator going to simplify? 2/3. In the numerator, I need to do 1 minus, and then I need to know what 1/3 to the 7th power is. What is 1/3 to the 7th power? Yes. 1/2187. All right, so the sum of 7 terms is 729 times, I know that denominator is 2/3. How does the numerator simplify? Yes, 2,186 over 2,187. What in the world should I do with this hot mess? We will put it in the calculator. What can I do to it first to make it putting it in the calculator easier?
Do it the first day.
Yes, let's multiply by the reciprocal of the denominator. So into my calculator, I'm going to have 729 times 2186 over 2187 times 3/2, reciprocal of the denominator. Simplifies putting it into the calculator a little bit, because then you don't have to worry so much about either your fraction notation or do you have enough parentheses around everything. Are we lucky enough to get a whole number here? Yes, 1,093. Beautiful. Do you guys have any questions for me about this? I have a question for you. That numerator, before we did the multiplying by the reciprocal and everything, so I'm just looking up at the numerator, that's that fraction in red, 2186 over 2187. That's really close to what? If I put that in my calculator and I actually divide the 2186 divided by 2187, it's really close to 1, right? That's going to be really important here in just a minute when we talk about finding the sum of an infinite series. Because where did the exponent of 7 come from? What did you say? The number of terms. So if I'm going to add up an infinite number of terms, what would happen to that fraction as long as, like, if it was, again, something like 1/3, so the numerator is still a 1, the denominator is going to be getting bigger and bigger and bigger, right? If my numerator is a 1 and my denominator gets bigger and bigger and bigger, the whole thing gets really close to 0, so I'm doing 1 minus something super tiny. So that numerator basically is going to simplify to a 1 if I'm looking at an infinite number of terms, as long as my R value is a small number. I'm going to skip these couple slides. We'll come back to these in a minute. This is what I'm talking about right here. An infinite geometric series. If the absolute value of R is less than 1, then the infinite geometric series formula simplifies to this. this part right here is still the same, right? If the absolute value of r is less than 1, what kind of number are we talking about? If the absolute value of something is less than 1, a fraction, or it could be represented as a decimal. So we have something that when I multiply by it, is my value going to be getting bigger each time or smaller? Smaller. If I'm multiplying by something that is less than 1, or absolute value is less than 1, then each subsequent term is going to be getting smaller and smaller and smaller and smaller and smaller. That means that this right here, if the absolute value of r is less than 1, then r to the n approaches, do you guys remember when we talked about limits? This approaches 0. And so then when I multiply these fractions together, I am multiplying the first term with 1. That's why the numerator is just that first term over my denominator. Does that make sense? That's where this is deriving from. When you've been asked to find the sum of an infinite geometric series, so not just a certain number of terms, but an infinite number of terms, the only way that you can do this is if each subsequent term is getting smaller and smaller. So r has to be in between -1 and +1. That's the very first thing you have to check. Because it can be really, really tempting to grab this formula and just use it, even in situations where it doesn't apply. So you have to check to make sure that this does apply, and then we can use this formula. So we check this first. Do a couple practice problems with this. I want to find the sum of the geometric series described here. First, we check to make sure that the absolute value of r is less than 1. They gave me sigma notation. This is my summation notation. And then this is the rule so what is the r value? What is the r value? Anybody? 2/3. Right here is our r value. So if I take -2/3 and I take the absolute value of that, what is the absolute value of -2/3? 2/3. Is that less than 1? Yes. That means an infinite sum does exist. So now that I know an infinite sum exists, I can use my summation formula for an infinite sum. We don't have the little n next to it, even though I accidentally wrote it for a second there. Because we're not summing n terms, we're summing an infinite number of terms. What pieces can I substitute in? Down on the bottom, I can substitute in r. I have 1 minus, and then what is our r value? Negative 2/3. Yes. To find a sub 1, we need to substitute 1 in the place of n. So a sub 1 is equal to 3 times negative 2/3 to the first power. What is negative 2/3 to the first power? Just negative 2/3. So I have 3 times negative 2/3, negative 2. So that's what we're going to put up in our numerator. So far, so good? All right. How's that denominator going to simplify for us? What'd you say? 1 plus 2/3. What is 1 plus 2/3? 5/3. And then how do I deal with that? Not times 1/3, but times 3, yeah. We'll multiply by our reciprocal there. So I'll have s equals negative 2, and then we'll multiply by the reciprocal, which would be 3/5. Negative 6/5, yes. So there's our infinite sum. All right. Let's try another one that's similar to that. I want to find the sum of this geometric series. What do I need to know about it first? Yes. First, we have to check that the absolute value of r is less than 1. What's r? .01. How did you find that? You're absolutely correct. Second term divided by the first term. So 0.015 divided by 1.5. Any two consecutive terms you can do this with. You would just take the one that comes later in the sequence and divide it by the one that comes right before it. And this gives us 0.01. Is that less than 1? The absolute value of that is less than 1. So an infinite sum exists.
Wow.
So let's find it. What goes up in my numerator? 1.5. Down in the denominator? 1 minus 0.01. What is 1 minus 0.01? 0.99. We are always supposed to leave our answers in exact form unless the directions say otherwise. If it requires rounding, we can't give that as a final answer. Pop this into your calculator and tell me what you get. 1.51 repeating. That means we would have to round this, right?
Or 50/33.
50/33.
What is the function?
Let's talk about how we get there, because that's absolutely correct. 1.5, and I've got 0.99. How can I rewrite 1.5 as a fraction? 3/2. How could I rewrite 0.99 as a fraction? 99/100. And now what can I do to simplify this so that I can have a rational number instead of a repeating decimal?
Is multiply?
Yes, we're going to multiply by the reciprocal. So I'm going to have 3/2 multiplied by the reciprocal. So 100/99. And that will simplify to 50/33. I will show you guys tomorrow how we can take something that is just in its repeating decimal form and change it into a rational number. We're going to look at that tomorrow. I want to do one more practice problem like this, and then we're going to talk about geometric means to kind of round out the class period today. So let's look at one more infinite series. I want to find the sum of this geometric series. What do I need first? Yep, got to make sure that I'm even allowed to use this. So we need to check that our common ratio, or absolute value of our common ratio, is smaller than 1. That means I need to find the common ratio. How do I obtain the common ratio?
Square root a minus 4 divided by square root minus 2.
So we've got, here's my first term. This is my second term. My third term, my fourth term. Any two consecutive terms I can divide. Jackie, if I heard you right, you picked A3 and A2. Is that right? Mm-hmm. Okay, so we can take the square root of 8 and divide it by -2. Can I simplify the square root of 8 at all? Yes, sir. Yes, you may. What'd you say? 2 square root of 2 over -2.
Yeah, it's something.
What's your question, Alex?
I thought like the square root of 2 minus 2 was one thing. Yeah. Like that was all A1.
Good question. No, it is not. We have 4 terms here. Anytime you see like a minus sign or a plus sign in between, basically if I were to write out this sequence instead of writing it as a sum, the sequence would look like this. Does that make sense?
Yeah.
I totally understand that it's written in a way that makes that kind of hard to see. Can I simplify this at all? Yep. So I can cancel that out. So what is R? Negative square root of 2. So I need the absolute value of the negative square root of 2.
It's called -1.41.
Yeah, we have the absolute value of -1.41, right? Is that
Yeah,
ballpark correct?
1.4.
Something, 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 yeah. It keeps going.
Ms. Bull, can we also do square root of 8 over square root of 2?
You can't do the square root of 8 over the square root of 2 because they're too far apart. They have to be side by side. You could do -2 divided by the square root of 2. Or we could have done negative 4 divided by the square root of 8. But they have to be side by side. Is this
No.
less than 1? No. So what does that mean? Can't do it. So does a sum exist? No. No infinite sum exists. All right. We are going to round out today with talking about geometric means. Mm-hmm.
Can't you use the last one? What's it like? Find the sum?
We could find the sum of the terms that they've given us, or we could find the sum of a specific number of terms. But without knowing how many terms they want us to sum, I can't find the sum of the infinite series. Does that make sense? Yeah. If they'd said find the sum of the first 10 terms, we absolutely could do that. Yes. All right. Geometric means. The definition of a geometric mean is that if I have two numbers, A and B, and they are both positive real numbers, then the positive number C is called the geometric mean if I can do A, C, B, and that makes a geometric sequence. All of these values will be positive. When we're talking about geometric means, they are always positive values. So we don't have to worry about any negative numbers coming in here. We're going to practice finding some geometric means. You guys okay if I put up an example? All right. We're going to find the geometric mean of 20 and 45. So if I were to see this sequence written out, it'd be 20, and then some number that I don't know yet, and then 45, and all together, this would make a geometric sequence. So what do we have to work with? A1 and A3. 20 would be the first term in the sequence. 45 would be the third term in the sequence. So we are looking for the second term here. We can use our general form for the nth term to determine what R is. Because if I know what R is, I can take the first term and multiply it by R to find the second term. The second term multiplied by R would give me the third term, and so on and so on. So if I can find R, I can find any term. We said we knew the third term and the first term. What are we using for n? We don't know R, but we do know n. N is 3. What are we using for k? 1. A sub 3, the third term in the sequence. What is the third term in the sequence? 45. So 45 is equal to, what's the first term in this sequence? 20. Times r to what power? R to the second power, r squared. What can I do from here? Divide both sides by 20. 45 divided by 20 simplifies to what? 2.25, or 9 over 4, is equal to r squared. What do I do from here? Square root both sides. Yesterday we talked about when I take the square root, when I take any even root, we get how many answers? 2, except with geometric means, it's only what kind of numbers? Only positives. So with geometric means, I don't have to worry about the plus minus. What is the common ratio here? 3 over 2. So here's my common ratio. I want to find the third term in this sequence. So C is equal to the term that comes before it, 20, multiplied by our common ratio. What'd you say? 30. Let's look at this and see if it makes sense. Sequence started with 20. If you multiply that by 3 over 2, or 1.5, you get 30. What's 30 times 3 over 2? 45. So we do have a geometric sequence here. I want to find the geometric mean of 3 and 4. So if I were to see this sequence written out, it would be 3, and then something, and then 4. A sub n is equal to a sub k times r to the n minus k. Tell me what to substitute in. 4 equals 3 times r to the power of what? 3 minus 1, because we've got the third term and the first term. I'm going to divide both sides by 3. So I have 4/3 equals r squared. Take the square root of both sides. I only have to worry about the positive one since it's a geometric mean. How does the square root of 4/3 simplify? 2 over square root of 3. Can I leave stuff like that? No, we have to rationalize that denominator. So my r value is 2 radical 3 over 3. So what is this missing value for C that I'm looking for? 3 times 2 radical 3 over 3. So what is our value for C? 2 radical 3, yes. So my sequence would be 3, 2 radical 3, and then 4. What happens if I want to insert more than one geometric mean? Can we do that? Let's try it. Let's try to insert 2 geometric means. We're going to do it between 4 and 500. So my sequence would be 4, and then we're looking for 2 numbers that go in between and then 500. Which means 4 and 500 are which terms? A1 and A4. So I've got the fourth term and the first term. What's my exponent going to be? 4 minus 1 equals 3. Sorry, I couldn't hear you around your yawn. So we're substituting 500 in the place of a sub 4. We're substituting 4 in the place of a sub 1. And then we have r to the third power. Divide both sides by 4. What is 500 divided by 4? 125 equals r cubed. And then I need the cubed root of 125. 5. All right, so I need C1 and I need C2. How do I find C1? 4 times 5. So that would be 20. And then we do 20 times 5. And that gives us what? 100. So my geometric sequence with the 2 inserted geometric means would be 4, 20, 100, and 500. Let's do one final problem and we'll call it a day. We're going to insert geometric means again. We're going to insert 4 geometric means. (48) is my first term. If I'm inserting 4 geometric means, 3 over 2 is which term? The 6th. Go ahead and find r. It is 1/2. Let's talk about how we get there. I would have a sub 6 equals a sub 1 times r to the power of 6 minus 1. So I'm going to have 3 over 2 equals 48 times r to the 5th. I divide both sides by 48. That is 3 over 2 times 1 over 48. So I have 3 over 96 equals r to the 5th. Does 3 over 96 simplify? 1 over 32. And then when I do the 5th root of 1 over 32, I get 1/2. So if r is 1/2, what's the second term in the sequence? First term is 48, second term would be 24, and then 12, and then 6, and then 3. Absolutely correct. All right. We still have one last thing that we need to cover in 10.3. We'll do that tomorrow right at the beginning of class. I've got 2 final examples for you. Homework over 10.3 is due tomorrow night. We'll start 10.4 tomorrow. 10.4 we're just going to do kind of a brief overview of. Test is next Thursday. I will have the reviews ready for you guys tomorrow so that you can begin preparing for the test next week. All right?